It's a recording. Yeah, so I won't read this, but this course focus on programming, so it'll be very practical. And you will install Python, Qiskit, and then start running code. Okay. Yeah, so there are a few learning goals. Okay. Let me also not read everything. So you already know quantum computation, the circuit model. And so we're going to really write code and understand the algorithm in terms of programming. I mean, you already learned some algorithm. What algorithm do you still remember?
Grover's algorithm, Simon's,
Yeah,
Shor's algorithm.
yeah. So we'll try to implement those. And we'll use Python because the framework we'll be using is mostly Qiskit, IBM's Qiskit, and maybe Pennyland, but they are written in Python. Okay, so who can code in Python? Okay, so most of you, but I will give some review of the Python, just make sure everybody. I'm not an expert in Python, so I use those tools, and many of you may be very good in programming, so it could be useful in revising some of those codes because the IBM Qiskit evolved very fast. Who knows Qiskit? Most of you heard of Qiskit, right? And the the version evolved very fast. So last year when I was teaching, the codes were already not working. So every year I have to relearn. So it's a lot of effort to actually prepare this course, mostly spending on making sure codes can work. Uh, which is not a problem because most of the code, even on the GitHub, doesn't work well. You need to change something. Yeah. So, but collectively, maybe we can do that in the class or in the homework. Yeah. And then if you register the IBM Quantum, then you would have 10 minutes of free time every month you can run on their device. That's not too bad because maybe some of the job you just need 1 minute or even less than 1 minute. If you don't do the shots, we'll explain what that means. Too many shots, that should be okay. And most of the time we'll do simulator. Just install Qiskit locally and just run on your laptop. Okay. This is the syllabus. So we're some overview, gates, and some simple algorithm. So before maybe Qiskit, we'll probably look at the simplest one called quantum composer uses track, circuit, gate, etc. And we maybe do some Grover and then introduce some VQE. The problem of that is the IBM's quantum algorithm, they used to have codes and those no longer work. And quantum algorithm now is maintained not by IBM, by the community. So it's called Qiskit ecosystem. And the community is maintaining that. It's not really up to date because IBM changed their Qiskit and some of the old function they deprecated. So at the moment it can still run, but in the future it won't. So what we are learning may be something already outdated in a few months. But we can try to update that. But to update, for example, the VQE using the newest framework will take a lot of time. It will take a lot of time. And this rely on the community to update. If they don't update, then we have to do it on our own. Yeah. Mostly is how you run the program, how you execute and the circuit, how you get the data. So we'll learn some of these. They call it primitive. And there's also a set of tutorial on quantum machine learning. this is also maintained by the community, maybe a different group of people. And this set of tutorial were mostly updated to the V2. We'll know what V2 is. Um, and then from here, maybe we'll switch to Penny Lane because it's also a framework that designed to do a lot of quantum machine learning. Yeah. And some of you may already have machine learning and even quantum machine learning experience. And later there will be more advanced algorithm, quantum Fourier transform, quantum phase estimation, shores, and maybe linear system. We talk about HHL. This would be something I would like to cover. And previously, okay, because there's no one from chemistry. If you're really interested, I can try to dig out those codes or try to find codes that are most updated. Don't guarantee they will work because I'm not sure the status now. Uh, we probably this semester we will focus more on the IBM Qiskit and Penny Lane. I think that would be enough tour. So probably we won't talk about D-Wave. We won't talk about Q-tip. Basically, I'm going to slash the second half and expanding the first half into one whole semester. Well, each of them can cover already a lot. Qiskit you can cover already one semester on its own. Penny Lane also on its own. Yeah. And the end, okay, so the end, as you know, we'll always have some presentation, project. Yeah. And
Can we do some of the squid?
let's quit. I I haven't updated myself on those. It's been a while. Yeah. I know maybe for you it's most interested. But you could do a project on that and then present. So because at the moment we only have 4 students registered, I don't want to have too many students. If you register them with 5, so each would do the project on their own, right? So then we can talk about what project could be. Yeah. Okay. Uh, Textbook. Okay, there's no textbook. The best place is IBM's website. So we go there. Let's see. We can use the other one. We can use the other. Maybe I'll stop share here and then use that computer here. Probably in order to record, I probably have to share this. Share this. Is it shared? Doesn't seem to. Wait. Entire screen. Okay, I'm sharing this one. This one I need to use this keyboard. Okay. Of course, Nielsen and Tran is the standard quantum information textbook. This one written by Jack Eatery is about quantum computing and Qiskit, but it's Qiskit at the time the book was written and was already outdated. So I'm going to probably drop this. Um, and they used to have a very good free book maintained by IBM and the community, but they no longer do that. So all the codes here, this is a very good resource in the past. Maybe it still is, and as long as we can update the code. Uh, yeah. So, but they no longer maintain that. So you say that this is 3, 4 years ago. A code written in Qiskit 3 or 4 years ago is definitely not going to be run on the platform. So so IBM decided to abandon this and then move the learning material into their IBM Learning. You can click along, and we're probably going to use a lot of these here. Okay, so there will be a lot of learning material, but it may not be easy for a beginner to, well, manage through everything, but you could follow their suggestion. So there, for example, computing practice, there's some course, um, some learning path. For us, um, we're mostly interested in the tutorial where there are codes, right? For this recorded video or material that you can read, you'll mostly read on your own. I can mention something in the class, but you'll mostly do the reading since you have taken my course. So that shouldn't be too much difficult for you to read, to watch the video. But we are mostly interested in the tutorial. And actually, some other tutorial may have come with a video. Those are really good resource. Okay. Yeah, and John Walters has a series of lectures. These are the basic information algorithm that we already covered last semester. So we're mostly interested in running codes, and you can see a lot of, for example, you learn CHSS inequality, right? There's one here, variational eigensolver, Grover, repetition code. Right? Some of these we may recognize. Error mitigation, we mentioned error mitigation, error correction, right? But there are a lot of new things in order to run on a real device, right? So it may be machine dependent. There's some instruction that only the machine recognize. If you write a circuit, you need to translate that into the machine recognizable instruction. So that thing is called, there's this word transpile. So you need to be able to translate this circuit into machine recognizable instruction. So there are a lot of these we have to learn. Okay. So yeah, let me continue with the slides. Okay, any question here? So this will, yeah,
Yeah, will we be possibly exploring Amazon bracket?
Amazon bracket, no. So Amazon bracket would have their own programming framework. It's called bracket. But the most developed is Qiskit. Even you could, there are machines on Amazon that you could also run using Qiskit, like IonQ and others, like Rigetti. You can also use Qiskit to run.
And Panelin also offers integration with AWS packet. There are a few tutorials.
Yeah, yeah. You can do a project to present if you want, but I don't want to make the scope too large for the material. This is Qiskit and Relay. Yeah. Okay, so I think I would have some homework, not every week, maybe every 2 weeks. And then I'm not sure I'm going to have quizzes or midterm, or maybe just some presentation, and for each of you to present something. Uh, I was thinking, I was looking, there's only 4 registered students, and last summer IBM has a summer school. In each summer school, they always have the lab. So there are 4 problems. I was thinking each of you present those 4 lab. Yeah, right. So the summer school they have is usually 10 days, 2 weeks, and it's open to anyone, right? Even without quantum mechanics background. And if those participants can finish those 4 lab, why can't we, right? So and we should even be at a better ground because we have learned confirmation in theory, right? And we just add the programming part. Yeah. So we're thinking those material could be presented. Um, yeah. So then that will be the final. So you see homework is half. So and also developing homework problem is also hard for me because I have to update. Yeah. Maybe what you can do now is set up that account. So you just need to go to IBM quantum computing IBM.com and set up account. It's very straightforward. You can use any email. Uh, Once you set up the account, you can log in. Then you will see a few panels, and these are the current machine that's accessible. So there are, I think, 11 machines, but because you will register, you will have only for the open those machines open to the public, maybe just a few, 1 or 2. Yeah. If you see locks, that means these are machines you cannot access. So I do have other access, so I can access these machines. But now you can maybe start register. So yeah, it should be straightforward. If you don't want to register, it's fine. But then that means you cannot run on the real device. You just run on your local simulator. Scroll down. Yeah. If you have an account, you can access. You can even see information, even though you cannot run on the machine. For example, this is IBM Torino, has 133 qubits, and this is the structure of the qubit. Each dot is a qubit. Each link is uh, where the 2 qubit can have a CNOT gate. Okay. Yeah. Okay. So yeah, so I'm just saying this will be hands-on. You can register now. Start classes lectures. We'll run codes. So it's like combined lecture, lab, and everything mixed together. And yeah. And sometimes you will present instead of me. Uh, we'll do a demo, but I couldn't find the notebook. I was trying to move and then upload. I might accidentally move it somewhere else. So maybe while you are registered for the account, uh, I can try to find it. So Yeah, I think you can go to IBM. For example, if you go to sign in, and then there is a create account. Okay. Yeah. I can pause this. IBM Learning has hello. We just register an account for IBM. Your account. And installing Python, you know the Python, and then install. We're going to install Python Qiskit. Where is the basic? Actually, yeah, there are various courses. Uh, okay, so there is this website, Introduction to Qiskit, and also show you how to install Qiskit. There is a video. This is their researchers, Derek Wong. He has a video of how to install Qiskit. So maybe I play this video while you guys are. Are you registered with the account? Yeah. The next will be install Python Qiskit. He will talk about that. So I don't need to repeat it.
Tip 1. I'm your host, Derek Wong, and this is episode 2, where we'll be installing Qiskit 1.0 and getting ready to access quantum hardware offered by IBM. With all the tools
If
that
you
are in
need to
place,
stop,
we'll be well
let me know
underway
because
for utilities
some
to
step.
develop quantum computing
Yeah.
purposes. So first, let's install Qiskit 1.0, a Python-based SDK. This section is for you if you're totally new to Qiskit, and if you've installed previous versions, you should instead skip to the next section. I'll be focusing on the process for Macs, if that's what I happen to have. But if your machine is working Windows or Linux, don't worry. This part is similar when installing any other Python package, and we've linked some of our favorite resources in the description below.
If you have
First, we want to
problem
install
when you install, let me know. And
Python environments.
there are
Projects where you might want to
Python
have
experts
separate
there,
Python
so
environment.
he can help.
So we'll open my laptop and open a browser, start doing this. Open up a new window, and I'm just going to Google Python. There's a website, And first, I want to talk briefly about whether you should get Anaconda versus Anaconda. They both include the Conda package, which is a commonly used Python environment manager. In this case, I have to know exactly what packages I want to use. It's Qiskit, and I don't want a large download. So in this case, I'm going to be using Miniconda. So I'll click on the tab for Miniconda here and go into installing it. And what I'll do is scroll to the Mac OS graphical installer, since I do have Mac here, and then download the installer. When you go to this page, you'll see that they have different links corresponding to different platforms. There's Windows, there is Linux down here, but I have Mac. So you can see even within the Mac, they have different options. You can install from a bash script, or you can install using this package that corresponds to a nice graphical installer. I'm going to use the package this time. But even among this, you can see you have some choices. You have the Intel chip versus the Apple M1. In my case, to check that, I'm going to go to this button over here in the top left and click on About This Mac. You can see that I have an Intel chip right here, so I'm going to get the Intel package. Just click on that. It'll go to my Downloads folder, and we'll just open it up. So here I'm going to drag it onto the screen, just click through it. This is a README. Here's the license. You should read quite closely. I'm going to agree to it and install a specific part like this because I just want to localize everything out in the series folder to keep things clear. So earlier I created an account just for this EWQ Qiskit, and I made a folder called Code. So I'll just put it right inside here. Continue, let it do the installation, and just wait a minute or two as this finishes up. Okay, so it's finished installing. Close out of the graphical installer, move to the trash. We don't need it anymore. And now what I'm going to do is open a window of my IDE. And this is basically an environment where I can write code, edit it, and then access the terminal. For you, you can either use terminal or do your notebook or Chrome. I just tend to like Visual Studio Code. It's free, it's pretty powerful. So the first thing I'm going to do, now that I have Conda installed, is create a new environment in Conda. To do that, you need to open a terminal. So I'm going to click this terminal button here. And you can see that I have Conda installed because I'm now in my base environment. But what I want to do is create a new environment so that everything I make for this project and this series is localized. They don't interfere with other projects I have going on. So to figure out how to do this exactly, again, I'll go back to the Conda documentation, and I'm going to figure out how to create a new environment. So just Google it, look at the documentation here, and it'll tell me if I want to create an environment, I just do Conda create. Dash name, and I'll put the name of it here.
Okay, so maybe all of you have, we don't need to play this video.
Name, and let's call this
Professor, would you like us to prioritize creating virtual environments or not?
create the environment.
I think virtual environment is
It'll ask if I'm sure I
convenient.
want to do it.
That you know which.
And hit go.
For now, I'm
Okay.
using virtual
Now that
environment. I'm not an
environment,
expert. What's your opinion? I think virtual, because you separate what. Yeah.
I'm not using, but I recommend
Part
you.
here,
I think the process is even more
the
important.
first thing I do every time I create an environment is to
Don't
install.
Okay, so
Yeah. YouTube project environment.
so I'll stop the video because I think most of you already have Qiskit. Everyone has Qiskit. Okay, now I just uploaded one. I just uploaded one. Let me do this. Wait, I want to stop this.
So what it'll do is make sure.
And also the IDE. I think the studio, what's it called? Studio Code, Visual Studio Code. I think it's very useful. Although I'm not using that. I think it's very good, and he's also installing that, telling you how to install that. Because I don't know how to install that under the Windows this WSL.
I want to add
Yeah.
a comment.
Yeah,
So when you are installing Miniconda,
I'm not in.
it will ask you if you want to add to the path.
Yeah.
And yet strongly recommend you not to do that,
Not to do that.
but actually please do that.
Okay.
Or otherwise you will have another trouble.
Okay.
So accurate test.
I'm not using mini countdown. I'm just using the Linux.
Oh, Linux.
Linux.
You also need mini countdown on Linux.
Yeah, but I'm not using. I think you can. Okay, so if you go to our course in the content, I just found a notebook, and you can download that. But I'm going to just show you. This is just an overview of Qiskit. I have not done with my introduction slide, but I'm going to just, since you have that, you can actually run alone. But so maybe I switch to my other. Okay. Yeah. Oh, so not just Qiskit, you may also install runtime, Qiskit Air. There are a lot of packages. Yeah, if you have questions, then just let any of us know. Because when you try to import or you try to run, it said there's no such package. That means you need to install. So that's right.
I have Qiskit 1.1 should have.
Yeah, you update that. 1.1 is probably okay, probably can run, but maybe update.
Yeah. The API changes.
The newest is now is 1.3.2. I'm still using 1.3.1, but yeah, that probably is okay. I'm sharing screen now. Okay. Okay, so this is I'm trying to update code, so we'll have that later. There's some algorithm called random shift. I'll try to update that, but yeah. If you download that, okay. Yeah, I'm trying to update a lot of codes, and also download other people's code and revise it so that it can work here. So you have these L0. Let's see this here.
This is your computer.
This is my computer, but I hope I didn't move that. Did I lose that? Yeah. Okay, so I think I accidentally using move, so I moved the code to the folder that I upload, but I'm going to copy back. So you'll download that notebook? This is the okay. Oh. Okay, so I'm going to open that. This is like an overview of Qiskit, what you expect. So let me open this. Okay, so you have this, right? And oh, you may also need to install the matplotlib so that you can draw the diagram nicely. Okay, so you can follow along, right? So you import the Python, you import its package, or they call module, right? This is Qiskit that you import quantum circuit. Okay. I commented at least out because we'll import that along the way. So if you say circuit equal to quantum circuit, 2 is 2 qubit, okay? And you say circuit dot H is to add a Hadamard gate on qubit 0, and circuit dot CX is control NOT, control X gate. Control is from 0, target is 1, right? And you have that, you can draw, you say circuit dot draw. MPL is using matplotlib to plot. If you don't do that, then it will be just a text. Okay, so for example, if I draw this, right? So you will show this. Okay, you can follow along. And if you just draw without any argument, then it would be text. It will be just a text drawing of a circuit, okay? And so I add mesh, so you can see the circuit, right? I can also add measurement. I say measure all is I'm going to measure all the qubit, but you could also say measure, just measure and 0 qubit, and then you need to have a classical register. So 0 measure 0 0, for example. Yeah. Okay, here I'm measuring all the qubit. Okay, and here next I'm going to use this called state vector sampler. I'm going to run the circuit and see how many what are the outcome I get, how many I have. Right? So I import state vector sampler. So I'm just showing you the overview. So the detail we can explain more later. And I say sampler is a state vector sampler. And I use the sample to run the circuit. And I say shots is 1024. This is like how many experiments I'm going to do, repeat, okay? So I run this. Here I need to get the result. So we say this job names dot result, and we get count. How you get the result from this. Okay. So they have a, okay, if you want to see, it's this, right? So the count is 0 0, you have like 525, 1 1 is 499, right? In principle, it should be 50-50, but this is a sampling, so this is finite number effect. Okay, so I don't want to go to the detail, but you can print out the result. Print this result, but it has these structure. So that's why we need to get the data from this metadata, and we say measure and get results. It's a bit complicated, but this is how you get the count. The count is sort of embedded here. Okay, and you can plot when you install Qiskit. If you have also include a visualization, then you can import this plot histogram, and you can count. You can add this. Okay, and you can plot the count. Okay, you follow? Let me see. So next, we're going to use estimator. So this sampler is like sample the distribution. Okay. This is the new thing that the IBM want to move on to. Before you could just say the machine, they call it backend, could be simulator, you just start run, and they give you these kind of counts, like what is the result, what is the number of shots you get, right? They want to move this to primitive called estimator and sampler. We just saw the sampler is similar to that run before, and estimator is estimate observable. Okay. So, but in order to use the simulator and estimator, I do not need to have result. So I'm using this function remove final measurements. Right. So see that I have measurement here in the circuit. Right. I have measurement. Right. I have measurement at the end. So I'm going to remove all the measurement, final measurement. So that I just remove the measurement. And now I'm going to define observable. So I'm going to define Z observable, X observable, right? You know this from the course. ZZ is sigma Z tensor product sigma Z, Zi, Ix, Xi, Xx, etc. But you are going to import from Qiskit.quantum info and import sparse for the operator. Sparse is that maybe you have 20 qubit, and these Pauli matrices tensor product is a sparse matrix. So they use this sparse Pauli operator, right? And I just put a list of these observable. Okay, and data is just for later to plot the result. Okay, so I define this, and I'm going to import a simulator. So this is a different simulator. We'll have more detailed discussion on these different simulators. It's quite sophisticated, so many of them, and it could be confusing. And now you have to import Qiskit runtime estimator v2. There's an estimator. There's an estimator. If you don't add v2, that's the v1. But they are not abandoning the v1 soon. So we'll just focus on v2 now. This estimator is to estimate these observable. Okay, so that's the purpose. And then you say run estimator.run. And the input parameter is a list of tuples which contain the circuit and observable. And this is called pop. Its name is primitive unified blocks. So, but that's the argument. So we'll learn this. I'm just giving you an overview. So you run this, and we can get a result, right? Get a result. Result 0. The reason we say 0 is because we have the pop here is a list, and there's only one, right? And Python start numbering from 0, and you say data that expectation values, so EVS. So those results would be there, and then we just plot the data. Data is the label, and the result is what you get from the simulator. I can print the result here. So you have. So result would be a list of numbers that are according to the observable we put in, right? The list of observable. You see here there are a list 1, 2, 3, 4, 5, 6, right? These 6 number corresponding to 6 observable, because we put the observable here. Okay. Yeah. Any questions? So we have covered the sampler and estimator. We actually know this before. You know this before, rough. Okay. Okay. So they sort of advertise that the whole process is called Qiskit pattern. You would convert your problem into circuit, and you optimize the circuit, and run on back end and in post process. So that's they sort of now says, okay, this is our Qiskit pattern. You follow these kind of steps. Then instead of running on the real machine, we're going to load a fake machine called fake Sherbrooke. You can see, maybe I can show you I'll show you the devices, right? Devices. Sherbrooke is probably no longer here. Okay. But there's a fake one you can use. Okay. Okay, so so there are a lot of updating. The fake machines usually in I think Qiskit provider, fake provider, but they moved this to that. Now it's under IBM runtime. So I'm going to import fake Sherbrooke and spec end. I call this spec end. There's something called optimization level is when you translate a circuit into smaller gate instruction, how you want to optimize. So if you say optimization level is 0, they don't optimize. There's some sophistication of optimization. Okay, and so here is the main step to translate. They call it transpile. So you have to, because you are running on a device, right? And you need to know what the instruction the device set. So you have to translate that. They call it transpile. To transpile, transpile is its own topic, but you can load this generate preset path manager. So there is a path manager that help you to transpile. So you basically say that I'm going to load this path manager with backend equal to the fake Sherbrooke. Optimization level is 1. So I have some mild optimization. And then you transpile the circuit. Okay, the circuits. You just say path manager.run circuit. You translate. Okay, so previously it's just Hadamard and control nut, right? If you transpile, you can show the transpile circuit, like it's shown there, but let me just run this. Okay. So now it will take some time because it's doing some optimization. The few steps in these I think there are 6 steps in the path manager. We'll talk about that later. But see, when it translate into these base the base gate that the machine can run, this RZ square root X RZ, and this is not a control nut, but this is like so cross resonance gate, and this is like RZ square root. Yeah. So it's very different from this, right? Right. It's very different from this. So I think one can do is also you can see why it's using these gates because that's the Sherbrooke's gate, native gate. Let me see. I have to look up the instruction to see what the backend basis gate. Does anyone know the command up there? Let me see if I can. I want to justify why they translate into those gates.
So I have to go.
Yeah, that's fine.
Oh.
Okay.
You
Okay. Qiskit, back end, basis gate. Okay. native gate operation. Okay. Maybe it's here. It's backend configuration. Oh no, this is deprecated. Yeah, a lot of time you were going to read these documentations. Okay. Backend property is what we want. Initialize. But these are deprecated, so I don't. What is the?
Professor tries circuit construction because I think in
Yeah.
the API they would not have any specific information around this. The second option in the list on the left, circuit construction will be there. That's where they'll give a better explanation of transformation.
Yeah, I know. Circuit, you mean circuit? Yeah, they will have a lot of these. What I am trying to do now is just to, you have the back end, you want to print out what the basis gate is. I think there's some property, but it would be too much. I think you could have back end properties. Yeah, but you want to know what property. Maybe let me see if I could get it. Basis gate. I'm not sure I will get this, but oh, it's or maybe this. I'm not sure. Okay, trivial basis gate is not defined. So basically, I want to print the backend property, so it only show these gates. The key error. Oh, maybe you think this is a dictionary? It's not, so it's not. There's also this configuration. There is a tutorial on
Professor backend configuration or basis case.
basis gate. Good. That's it. Yeah, you see. So this is what I'm trying to do. That's so they change these, but if we learn this and we put in the notebook, then we know next time we want to find the property, right? So you see that the transpile can only have these ECR, ID, identity, RZ, S, X. This is square root of X, and X. Okay. So you can only use this instruction. Okay. Right. And then once you transpile, what do I use? These code are not needed. Okay, next is so the circuit has been transpiled, right? It's actually transpiled to the fake backend, but assuming there's a real one, and because we want to do estimation of the observable. The observable also need to translate it into the corresponding qubit, because the circuit has transpiled already assigned. Maybe this is assigned to some other, maybe qubit 100 and qubit 101, etc. And the observable need to also be translated to the corresponding one. So what you do is you say observable list and then apply layout. And this transpile circuit would have the layout. Let's see if we can we print out what is the layout? We can also print out. So a lot of things you can try, right? Even I just wrote this, and there are a lot of things. For example, you can print out a lot of things for you to see. Transpile circuit, layout. Let's see what it shows you. Right, this is saying 0 is qubit 2, 1 is qubit, okay, want to register 2 and 1. So there is a quantum register that has 2 qubit, and this is the zeros 1, and that's 1, and 2 is translated to this register that has 125 qubit. It's called ancilla, 0 and 1. So these are the qubit that are not used, right? Remember, we only have 2 qubit in our circuit. So the first 2 are the one that's needed, and all the rest they call it ancilla. Okay, and then you need to translate that observable list, and that's this. So you translate that to call that observable list, and now you call the estimator, and you need to use mode equal to backend. The previous version, maybe 1.1 or something, it's called backend equal to backend, but you need to use mode in the newer version. And you say estimator.run. Also, the argument is the pop. Pop is the transfile circuit observable list. Okay, you use the tuple, and then if you have many of these, you can add them to the list. Okay, so we're done running, and you can plot the results, right? So the horizontal axis is observable, y is the value. So the line doesn't make any sense. It's just these stars that represent the value. You could also print out. Okay. I mean, you have the notebook. You could just play with that. For example, I wonder what the observable list is in the new transfile. What is the right? So you see that this is the transfile one, right? 1111111. C. The 2 qubit XX become these XX, right? XX. And this is qubit. The way they label it, this one is qubit 0, qubit 1. Okay. But I think it's the register that you see that the register, we print out the transfile layout, right? This is using this one, these two. These two are 0 and 1 are those qubit that get mapped to, okay? Right, so you can play with these code, and then you can get a job, right? And how you run on the real backend. Okay, so let me do this. So to run on real backend, you need to register. You have account, and then you need to call this service, Qiskit runtime service. The first time you call that, you need a channel. You go to IBM Quantum, put in your token. The token is in your account, and then you can save account. When you save it, next time you don't need to do that. You already save it. But how do I get rid of this? Okay, so I can run this. You also need to do, how do I dismiss? Well, dismiss. Oh no, the dismisses should be from dismiss. Okay. Yeah. So this is doing the translation. So it takes time because it's also real backend. Select. So I'm using the service, and I ask what is the least busy one. It says Brisbane. Okay. You can actually go see the Brisbane. You go to here and see Brisbane. It's here, right? You click view. You do not have access. Something's not quite right. Okay, so I think maybe the website is busy. Okay. But I was trying to click to Brisbane and see how many jobs are waiting there. Yeah, still loading. So maybe let's go back here. And let me not really run that, but you can do the same transpile circuit, and you transpile the observable, translate the observable and run it, right? And when you run, it's better to print out a job ID because it may take a long time for it to finish. You know, job ID, you can recover it later, okay? Just do the service.job job ID and get a result. And you just do the same thing as previous one, process the data, okay? So, and then if you have the account, you can really run it on a real machine. And you can run as large as the number of qubit you have, you can run a 100 qubit circuit. So it really is really close to the forefront of quantum computation. Okay. So we only have few minutes. So maybe what I do is I go back to my slides. Okay. So I hope, yeah, you get some sense of this. And so we're going to the detail later. Okay. Okay, so I've done this. Right. So if I had clicked Brisbane, then you will see that, for example, like this. Okay, I click Torino, and you see there's total pending job. If there are 500 jobs in front of you, probably you won't be able to run it soon. Right. Okay. Okay. Let's see. Yeah, you already done this. Yeah, and we already covered this demo. Okay. So next, probably we quickly review Python. Wednesday. So I'll upload some notebook if I can upload in time. If not, I will upload the class. And perhaps most of you already know Python, and we just need to have one class, a quick review of these conventions that you use in Python. Yeah, and class, some idea of the class. Yeah, we won't do too much sophisticated programming. We just use the package, right? We just use the module, use the function, and run. You need to know the full loop because if you want to construct large circuit, you would do a full loop, let's say from 0 to 133 or something. Right? If you want to use all the qubits. Yeah, so I think you have seen this, and I'll try to upload also the slides. Okay, any question? Any questions? So maybe I go back to the course website. Okay. Yeah, any question you have?
Yes, just a suggestion about the code.
Yeah.
So previously in the notebook, like the state runtime. Parenthesis assuming that the user has already loaded the course, because in the earlier version of Qiskit notebooks, they used to have it right at the start, the
Yeah.
loading that. So
Yeah.
right now what they're doing is, you take service is equal to whatever service you
Yeah,
choose.
and you can say.
And here, basically, the shows that here
Yeah.
they're using in the previous see, they have something like this. So maybe just replace it with service. So you just use this
So previously, what was what?
It was like Qiskit runtime service, but
Yeah.
I just changed it to this service. So otherwise, it causes a little glitchier code, and it's harder to understand
Wait.
if it's the first time in the platform.
What was being changed?
Here, backend equals service.vsp.
Just yeah.
Yeah.
I was using connoisseur. Qiskit runtime service. I see. Yeah. Yeah. So let me just say what she said there. Okay, so Noah said that you just here in in the runtime service, you just here, right? You just change it to service because I already defined the service. I don't need to call this again. I just okay. So you can change that yourself. Okay. So yeah, maybe that's it for today.